why use Prometheus? Before we answer this question, first let us understand what is Prometheus. Now, Prometheus is an open source systems monitoring and alerting toolkit that was originally built at SoundCloud. Since its inception in 2012, many companies and organizations have adopted Prometheus, and the project has a very active developer and user community. So if you have any queries, you can address them to the community, and I'm sure you'll have a very quick response. It is now a Currently, it is a standalone open source project and maintained independently of any company. To emphasize this and to clarify the project's governance structure, Prometheus joined the Cloud Native Computing Foundation in 2016 as the second hosted project after Kubernetes. Prometheus is free and an open source event monitoring tool for containers or even microservices. It collects numerical data based on the time series. So the Prometheus server works on the principle of scraping. This invokes the metric endpoint of the various nodes that have been configured to monitor. Now, these metrics are collected in regular timestamps and stored locally. The endpoint that was used to discard is exposed on the node. Prometheus works very well for recording any purely numeric time series, that is, it fits both machine-centric monitoring as well as monitoring of highly dynamic service-oriented architectures. Now, in a world of microservices, its support for multi-dimensional data collection and querying is a particular strength. It is designed for reliability to be the system you go to during an outage to allow you to quickly diagnose problems. Now, as we've already discussed, each Prometheus server is standalone, not depending on network storage or other remote services. You can rely on it when other parts of your infrastructure are broken, and you do not need to set up extensive infrastructure to use it. Prometheus is a pull-based tool. There are basically two kinds of tools that are currently present, that is a pull-based and a push-based tool. And Prometheus, as you can already see, is a pull-based tool. And as I've already mentioned in the previous slide, what the Prometheus server does is it works on the principle of scraping. That is, it invokes the metric endpoint of the various nodes that have been configured to monitor, and these metrics are collected in regular timestamps by pulling. Finally, the endpoint that was used to discard is exposed on the particular node. Now let's move ahead and understand the main reasons as to why one should use Kubernetes. Now, two technology shifts took place in the past few years that created a need for a new monitoring framework like Prometheus. The first shift that took was the DevOps culture. Now, prior to the emergence of DevOps, monitoring consisted of hosts, networks, and services. But now what developers need is the ability to easily integrate applications and business-related metrics as an organic part of the infrastructure. And this is because they are more involved in the CI/CD pipeline and can do a lot of more operations debugging on their own. Monitoring needed to be democratized, making them more accessible and cover additional layers of the stack. And the other technology shift that resulted in needing a new monitoring frame is containers and Kubernetes. Container-based infrastructures are radically changing how we do logging, debugging, high availability, etc. And monitoring is definitely not an exception. Now you have a huge number of volatile software entities, services, virtual network addresses, and exposed metrics that suddenly appear or vanish. Traditional monitoring tools are not designed to handle this. Now the question that arises is, why is Prometheus the right tool for containerized environments like Kubernetes? These four characteristics made Prometheus the de facto standard for Kubernetes monitoring. The first one is because of its multidimensional data model. The model is completely based on key value pairs, similar to how Kubernetes organizes infrastructure metadata using labels. It basically allows for flexible and accurate time series data, powering its Prometheus query language. The second reason is it has accessible format and protocols. Exposing Prometheus metrics is a pretty straightforward task. Metrics are human readable in a self-explanatory format that we'll see later on in this session and published using a standard HTTP transport. Later on in this session, we can check the metrics that are currently exposed by using our web browser. The third reason is it allows service discovery. Now, the Prometheus server is in charge of periodically scraping the targets so that applications and services do not need to worry about emitting data. That is, metrics are pulled, not pushed. These Prometheus servers have several methods to auto-discover scraped targets. Some of them can be configured to filter and match container metadata, making it an excellent fit for epithermal Kubernetes workloads. The last reason is because of its modular and high available components. Metric collection, alerting, graphical visualization, all of these are performed by different composable services in Prometheus itself. Now, all these services that I just mentioned are designed to support not only redundancy and also sharding. So now that we know what is Prometheus and why we need to use it, let's move ahead and understand what is Grafana. Grafana is a multi-platform open source solution for running data analytics, pulling up metrics that make sense of the massive amount of data, and to monitor our applications with the help of some cool customizable dashboards. What it really does is it helps you identify and tackle performance issues by giving you the tools you need to analyze and monitor your database. Not only does it help solve problems, but it also aids you in becoming proactive with your maintenance by using alert system management. Grafana is open source, compatible with a wide range of databases, and has a thriving community. It also supports a huge number of data sources, and since the application is open source, you can be sure that the moment a new data source has been released, someone out there is adding support for it. The most common use case of Grafana is displaying time series data such as memory or CPU overtime alongside the current usage data. Now that we know that Grafana is simply a data visualization tool, let's move ahead and talk about some of its prominent features. The first one is visualize. From heat maps to histograms, graphs to geomaps, Grafana has a plethora of visualization options to help you understand your data very clearly. The second one is alert. Grafana seamlessly defines alerts where it makes sense while you're in the data. It defines thresholds visually, and it can also send you notifications via Slack, PagerDuty, and much more. The third feature is unify. You can bring your data together to get better context. That is, Grafana supports dozens of databases natively. You can also mix them together in the same dashboard. The fourth feature of Grafana is that it is open source. Grafana gives you options. It is completely open source and backed by a vibrant community. You can also use Grafana Crowd or easily install it on any platform. Moving ahead, let's discuss and talk about Kubernetes monitoring architecture. Now, as you can see, there is a Kubernetes API. There are Kubernetes nodes. In the middle, we have the Prometheus server. We have the Prometheus Alert Manager. And then finally, we have Grafana. Now, in the first step, the Prometheus servers need as much target auto discovery as possible. And there's several options to achieve this. That is via Prometheus Kubernetes Service Discovery, or the Prometheus operator and its custom resource definitions, or even Consul SD, Azure SD for Azure VM, GCE SD for GCP instances, EC2 SD for AWS VM, and also File SD. Apart from the application metrics, we also want Prometheus to collect metrics related to the Kubernetes services, nodes, and orchestration status. For example, node exporter for the classical host-related metrics like CPU, MEM, network, etc. And also kube state metrics for orchestration and cluster-level metrics for deployments, pod metrics, resource reservation, etc. And finally, Kubernetes control plane metrics like kubelet, etcd, DNS scheduler, etc. Prometheus can basically configure rules to trigger alerts using PromQL. Alert Manager will be in charge of it. Now moving on to step 4, Prometheus can configure rules to trigger alerts using PromQL. Alert Manager will be in charge of managing alert notifications, ping, inhibition, etc. Now the Alert Manager component configures the receivers and gateways to deliver alert notifications. Finally, Grafana can pull metrics from any number of Prometheus servers and display panels and dashboards, that is the visualizations of data. So this is the basic architecture that you see. As we've already discussed, Prometheus and Grafana are pull-based tools. So all of these metrics that they want to scrape are pulled from their respective targets, and then they finally display based on visualizations or metrics, anything. Along with Prometheus and Grafana, we'll be making use of Helm, which helps you manage Kubernetes applications. Helm charts here help you define, install, and upgrade even the most complex Kubernetes applications, and this is exactly why we need to be working with it today. With this, we'll move ahead to the demo part of the session and install all of the tools that we'll be working with in this session. So now for the demonstration part, I'll be working on my Ubuntu virtual machine. So there are some prerequisites before we get on this demonstration. So the first thing is that you will need a Kubernetes cluster up and running. Kubernetes has a local cluster that is Minikube. So I have both Minikube and the command line interface tool that is kubectl installed on my virtual machine. So that is one thing. The second thing is you'll have to download Helm. As we've already discussed, Helm is basically a package manager for Kubernetes where developers develop and manage Kubernetes using the Helm chart. Okay. So now what we're going to do is we already have Minikube and kubectl installed on the VM, but we do not have the Helm chart up and running. So firstly, I'm going to check out the Minikube version for you all to know which version I'm currently working on. You can see that I'm working on Minikube version v1.20.0. Okay, so now let's start Minikube. I'm going to use the command sudo minikube start for this. And as you can see that Minikube is up and running. We have configured to use the Minikube cluster, and we have one default namespace that is named default itself. Okay. Now that we have Minikube up and running, I'm just going to clear my screen. So now what we're going to do is we are going to view all the namespaces that are available in the Minikube cluster. And I'm going to do this by using the command kubectl get ns, that is namespace. So once that is done, you can see that there's a default namespace which is active and created 13 hours ago. You can also see some namespaces. You can also see kube node lease, kube public, and kube system namespaces. So now what we're going to do is we are going to go and download Helm tool in our VM. So I'm just going to quickly switch to my browser and I'm just going to look for Helm. So this is the first result, and as you can see, you have Helm, the docs, charts using Helm, the architecture, and installing. So I'm just going to click on installing. This will redirect me to the official website of Helm, and this entire guide really shows how you can, download Helm into your OS. So there are various OSs that Helm can be installed within, that is Mac, Linux, or even Windows. So there are basically two ways to install Helm. The first one is the official methods to get the Helm releases. And the second one is through different package managers. Okay. So installation through these methods can be found on this page. So you can download Helm from the binary releases or from script or through package managers. Okay. So I'm just going to download it from the binary releases. And for this, there are 3 steps that can be followed. So the first step will allow you to download your desired version, and then you can unpack it and then find the Helm library in the unpacked directory and move it to the desired location, that is user local bin. So I'm just going to open this page, and this will take me to GitHub where all of the Helm releases have been put into. So currently I need to download Helm Linux AMD 64. So I'm just going to click on that. This will download a tar file of the Helm package. I'm just going to say, okay. I'm just going to click on this and I'm going to click extract. And this will allow me to untar it right here. So I can extract the file. So I can extract or unpack my package right here. So I'm just going to click on the extract option. I'm okay with extracting my file in home. I'm just going to say show the files and you can see that it's been extracted. Okay, that's great. Just going to close this window. Now that we have unpacked it too, we can skip this step, directly move the Helm binary into its desired location, that is user local bin Helm. Now I'm quickly going to switch back to my terminal and I'm just going to paste this command. So we're using the move command, that is MV. to move the file into the desired location. Okay. So once that is done, we have our Helm binary in our user local bin location, our desired location. Okay. So now that we also have the Helm binary in our VM, so now we're going to get started with the next part of the session. So the first thing that we're going to do is we are going to check the status of Minikube using the Minikube status command and check if it's up and running. So you can see that it is all configured and running. So what we're going to do now is we are going to look at our namespaces that are available, which we have already. So these are the namespaces that we currently have. So what I'm going to do now is I'm going to create a new namespace. Okay. So for that, I'm just going to use the command kubectl create namespace Prometheus. So I'm just going to use the command kubectl create namespace to create a namespace that is named Prometheus. All right. I'm just going to enter and it says a namespace Prometheus has been created. Okay. Now, if you want to view the namespaces, I'm just going to use the kubectl getNS command and you can see that the Prometheus namespace has been created. It's active and its age is 12 seconds. So once we have created our namespace, so now what we're going to do is we're going to install the Prometheus operator. Before that, we'll need to have the Prometheus Helm chart installed successfully in our VM. So we're going to do that. I'm just going to clear the screen. So for this, I'm going to use the sudo helm repo, that is repository add. We're going to add a new repository and name it whatever you want to. So we're going to add a repository that is named monitor. And I'm just going to use charts.helm.sh/stable. So I'm just going to use the Helm repository add command to add a new repository that is named monitor. And I'm just going to add the link to from where the charts can be installed from. Once that is done, I'm just going to click enter. So you can see that monitor has been added to your repositories. Now we're quickly going to update our repositories using the Helm repository update command. So just going to add all of the latest information into our repository. So once that is successfully completed, what we're going to do is, so finally we're going to install the Prometheus operator into our local machine. Okay. And now we need to make use of the Helm chart of the Prometheus operator to deploy Prometheus and Grafana and many other services, in fact, that have been used to monitor Kubernetes cluster. So for this, we're going to use the command helm install Prometheus monitor. This is the repository name /Prometheus operator. So we're going to just specify the namespace that it has to be installed within. So you have the helm install command and we are going to install Prometheus into the monitor repository and I'm going to click enter. So now you can see that the Prometheus operator has been installed successfully and you can check its status by running this command. So before we do that, what we're going to do is we are going to check the pods that have been installed in our namespace Prometheus. So for this, you can just use the command kubectl get pods -n Prometheus. So the flag that we specify here, that is -n, allows us to choose our namespace. So if you want to, find the pods of the default namespace, you can just specify this flag and then mention the name for it. So we're just going to check out the pods that are currently present in Prometheus. You can see that we have the alert manager that's running. We have Grafana, we have Cube State Metrics, we have Prometheus Node Exporter, we have the operator, we also have Prometheus running. Okay, so this is great. So what we're going to do is we're going to activate the Prometheus server. And how do we do this? We're just going to simply use the command kubectl port forward, and we're going to specify the namespace. We're just going to copy this entire pod name, and I'm just going to paste it. So you have to specify the namespace that you're working on and repeat. So we're just going to use the kubectl port forward command. We're going to specify the namespace, specify the name of the pod, and then finally specify the port that it can run on. Okay. And I'm going to quickly switch to my web browser, and let's check out if Prometheus is up and running. This is how the Prometheus time series looks like. There's a navigation bar on the top. You can see alerts, you can see graph, you can see the status, you can see different rules, targets, the service discovery. You can also get help from the Prometheus community. And you can add an expression here. You can execute it and view it in graph or in the console. So if you click on the insert metric at cursor option, you get many queries that you can work with. Now, if I want to check the kubepod info, okay, I'm just going to execute this command, which shows the node count and the value is currently 1. If you want to check out the graph, you can just click on the graph option and it will execute the graph. Okay. And if you want to see the memory available, okay, the sum of the memory that is available, you can execute this command and you can see the value on the right hand side. There's several other queries that you can execute, and we're going to do that now. We will check out the namespaces that has been created. Okay. So you can see the instance, you can see the namespace. As we've already noticed and seen before, we had 4 namespaces initially. One is the default namespace that is created by Minikube. Then we had Cube System. Then we had Cube Node Lease. And then we had Cube Public. But we created and we created Prometheus. So we have 5 namespaces. That is great. Also, if you want to check out the node information, you can execute this command. And you can see the container runtime version, that is Docker, the endpoint. You can also see the job. All of that can really happen within the Prometheus. Now, if you want to create your own rules, you can create them henceforth from here onwards. You can see the alert manager rules. You can also see the etcd rule that is present in Kubernetes. You can see the K8 rules, that is the Kubernetes rules. All of that can be accessed via the status option. You can also see the targets. Currently, we have the alert manager up and running. We also have the API server, which is up. You can see that the kube controller manager is down. All of the statuses of each of these targets also can be viewed in this command. So this is a pretty important option in Prometheus itself. If I want to view the command line flags, I can just check them out here. You can see what port it is running on, the external URL, all of that can be viewed here. Then when I click on the runtime information, you can see that the working directory is Prometheus and all of the information, the Go version is mentioned here and the Prometheus version is also mentioned here. You can see the number of series in the alert managers. You can see the endpoint. All of that can be viewed here. Okay. Now I'm just going to click on Prometheus. So all of the monitoring part of the data can be done on Prometheus. Let's move ahead and talk about Grafana. So for this, what we're going to do is we're going to quickly switch back to this. Okay, I'm going to clear my screen. So what we're going to do is the Prometheus operator itself installs Grafana and Prometheus with other deployments, right? We saw that. Now with the installation of the Prometheus operator, Grafana is also installed with it. We can access the Grafana dashboard by the port forwarding the Grafana pod. So we're just quickly going to view the pods that are present in the Prometheus namespace. Once that is done, we're just going to use the kubectl port forward command. So we're just going to add the Grafana pod in this. I'm going to quickly copy paste this option. And I'm going to click on port 3000. Now what I'm going to do is go to my web browser and we will look for what's there in port 3000. Okay. you can see that there is a welcome page to Grafana, and also it will prompt you for a username and password. Now, to find out this username or password, what we're going to do is we are going to switch to our terminal, and we are going to use the get secret command to, check out the password and the username. So I'm just going to type that out. kubectl get secret. I'm going to specify the namespace. So you will get the admin password and also the admin user here. So as you can see that the secret data is encoded with base 64, and you can only decode it so by using a certain command. But before that, if you notice that the admin password has been decoded and also the admin user has been decoded. So what we're going to do now is we are going to get the username using the command openSSL base 64-d. So this is taking a considerable amount of time to load. I'm just going to clear my screen. So now what we're going to do is we're going to just use another command. So we're going to execute the command and get our admin user and password. Once that has been executed, we are just going to check out the admin username. Okay, so we are just going to echo this and base64, and you can see that the admin username is admin. Okay, and the same thing we're going to do with the password. Okay, we're just going to type in echo and add in the password and decode it using base64. You can see that the password is prom operator. So I'm just going to execute the command kubectl port forward, and I'm just going to execute this. So we'll quickly switch to our login page, and you can see that the username is password and password is prom operator. So once you're logged in, you're redirected to the Grafana page, and here you can see that this is the basic structure of Grafana UI. You have panels that you can really move around with and play. You can increase them in size, you can decrease them in size, most of it is made of panels. If you scroll down, you can see some, information from their blog and community. You can add your first data source, you can create your first dashboard, and you have some icons that are present on the side. You can search for any dashboards that you create. You can create dashboards, add folders, import data. Also, you can manage your dashboards and your playlists, your snapshots. You can explore, you can access alerting. In the configuration options, you can add data sources. You can search for data sources or add whatever you'd like to by clicking on the add data source option. You can check out the user. If you want to create teams, you can do that. You can check out the various plugins that are available, the preferences, and API keys. Okay. So this is the brief overview of how Grafana user interface looks and how it really works too. So now what we're going to do is I'm just going to click on dashboards and click on manage. So by default, Prometheus operators are deployed with some pre-configured Grafana dashboards. And to see this, you can click on manage on the dashboard options and you can see the default dashboards. So if I want to click on compute resources namespace, this will give me a complete overview of the CPU utilization, the memory utilization, and you can see the CPU usage in the form of a very colorful graph. And you can also see the CPU quota, you can see the memory quota, the network. You can really, see these panels. If you want to, you can move these panels, you can arrange them however you'd like to. All of them can be done with these default dashboards that are available. Now, there are several dashboards that are available. Now, if I want to see the volumes, I can also click on this option. Okay, and you can also create your own dashboard. You can add your own data source via Prometheus, and then you can really make your own dashboard. So let's move on to the next part of this session.